Good afternoon, good morning, or good evening, wherever you are in the world. My name's Nick Chubb, and as you can see on the screen there, happy World Maritime Day. Welcome to the latest webinar in the Ship Navigation Voyage Optimization series brought to you by the S Group. And I'd like to start with a quick thank you to our sponsors, Coach Solutions and Signal. We'll be hearing from both of those organizations a little bit later on today. It is coming now into the closing stages of 2023. There's only 95 days left in the year, and moving on from 2023 takes us into 2024 and ultimately 2025, which is when the United Nations have requested that the world peak and then begin to reduce global greenhouse gas emissions if we're able to stay anywhere close to 2 degrees of warming. That puts us under quite a lot of pressure as a maritime industry, and that puts everyone who's in the audience here today under some pressure to be able to peak and begin to reduce emissions across their operations. And that's what we're here to talk about today, voyage efficiency for not just CII compliance, but regulatory compliance more generally. I'm pleased to say that we've got a fantastic panel of experts who will each be speaking in turn as we go through the through the afternoon. Starting with myself, I'll give a bit of an update on why I believe that we're hitting a tipping point on voyage efficiency. We then have Christian from Coach Solutions with some practical advice on managing and bringing down CII and tramp shipping. We have Pasquale from D'Amico, who's going to talk through their strategy for voyage optimization. And lastly, we have Harriet from Signal looking at the impact of crew behavior on efficiency. I think taking lessons from aviation through to the maritime industry. And of course, most importantly, we have you, all of you who are in the audience today. You'll notice on your screen there is a Q&A panel. Please, at any point, if you have a question or something you'd like to ask, put to one of our expert panel or a discussion point, please do. We'll try and make some time during and after each of the presentations to be able to answer any questions you have, but we also have some time at the end scheduled for Q&A and discussion. So really looking forward to hearing your thoughts, hearing your questions, and putting those questions to our expert panel. So first off, I will just run a quick screen share and bring the presentation up. Just by way of kicking things off today, I'd like you to just have a bit of a think about unleaded petrol. I don't know if you remember unleaded petrol. We haven't used it for some time, or at least most of us haven't. Have a bit of a think and a guess as to how long it took from scientists first discovering that lead in petrol was dangerous to lead being taken out of the fuel supply chain for cars. Have a bit of a guess. How many years, how many decades do you think it took for that process to happen? The answer may surprise you. It's actually 97 years. We first realized in the 1920s that lead was dangerous, and not just in the factories where it was being put into the fuel supply chain, but also in cities where there are lots of cars, the damage it was causing on the local environment. The last leaded petrol pump actually didn't close until 2019, which is when Algeria finally ran out of their stock of leaded petrol, and we moved to have lead fully out of the fuel supply chain. So that's nearly a century to take one fuel additive out of the automotive fuel supply chain. And in the shipping industry, obviously, we're looking at trying to change not just the additives that going into our fuel, but the entire fuel supply chain in about half that time. So there's a huge task ahead of us in terms of actually being able to decarbonize shipping in a meaningful way. And on the subject of that huge task, I'll again invite you to have a bit of a think. What do you think that is on the screen there? If you've made any guesses to yourself, and congratulations if you get this right. This is actually one of the first patents for a dual fuel engine, LNG and heavy fuel oil. And you'll see there on the bottom right of the screen, you'll see the priority date on it. The patent was filed in 1969. So that was when we were first looking at using LNG as a marine fuel, and first starting to develop the engines to make LNG a potential fuel of the future. And it's taken, I would say, up until the mid 2010s for LNG to become something of a mainstream alternative fuel for the maritime industry. So we're talking there about something close to a 40-year timescale. Why am I telling you that? Because when we look at alternative fuels for the maritime industry of the future, for example, fuels such as ammonia, we don't even necessarily have the engines yet to be able to make those fuels viable, let alone develop the fuel supply chain. So there is a massive, massive task ahead of us as an industry. To give you some context on why I'm telling you all of this, I work for Thetius. We provide research on emerging maritime technology. A big part of our work now is focused around maritime decarbonisation and the technologies that will enable it. And we track through our decarbonisation outlook where investments are happening, where they're having an impact, and who's involved with them. So we've got a pretty good handle on sort of what's going on throughout the maritime sector. And this is what the last 12 months looks like. It's about $32 billion US invested in the year 2022-23. So this is up to about June 2023. And you can see in previous years, the numbers have been significantly lower. So when I say we're at a tipping point in terms of decarbonisation, I really do mean it. We've had more invested in the last 12 months than we've seen in decades previously. However, it's not necessarily all good news if we want to peak and reduce emissions within the next year and a half. Of that 32 billion, about 30 billion has gone into alternative power sources. So things like ammonia, methanol, battery power, hydrogen as an alternative fuel. And only about $2 billion has been invested into optimization technologies. So technologies that can actually help us to improve the efficiency of the existing fleet. Now, I think it's a fantastic thing that so much is being invested into alternative fuels, but there's definitely an underinvestment happening into optimization technologies, and those technologies that can enable us to quickly improve the ton-mile efficiency of the global fleet. I think we're going to talk about many of those technologies this afternoon as well, so I'm really excited to have that discussion. Looking at the voyage optimization market more generally, this is from our voyage optimization market landscape. There's actually a huge number of suppliers out there that are working in the space. There's sort of 50 or so of the leading ones on your screens in front of you there. One thing that's worth pointing out is on that right-hand side, you can see just over 50%, 54% of suppliers in this space are actually small and medium enterprises. And so when you're evaluating what voyage efficiency technologies to be using or voyage optimization technologies to be using, it's absolutely worth casting your net wide and speaking to as large a number of suppliers as you possibly can. There are lots of suppliers out there that don't necessarily have the scale of some of the big technology companies, but are very, very innovative and producing solutions that can really make a difference. So it's absolutely worth making sure you're out having those conversations. And then finally, from me, I would say it's absolutely worth just looking at the decarbonisation market more generally. There is a huge amount going on now. So this is a decarbonisation market map from 22-23. So this is leading buyers of decarbonisation technologies and leading suppliers. And you can see, if you look at the buyers, this is where we have evidence of contracts being awarded to support decarbonisation, and that's either alternative fuels or voyage optimization. You can see that there's a lot of leading companies who are investing heavily into future decarbonisation technologies, and a lot of suppliers across not just the alternative fuels supply space, but also the voyage optimization space, that are going to help the industry to get there. So I really do feel that this year, more than any other, we've reached a real kind of tipping point for maritime decarbonisation, which leads to a question from me, which I'd like, if we can, I'll ask the producers to just chuck up onto the screen before we move on to any of the other speakers, which is how well prepared do you feel your organisation is to be able to take on voyage optimization and comply with emerging decarbonisation regulations? I think it would just be a really helpful starting point to ask the question, how well prepared do you feel? That might help to give some of our presenters who are coming up a bit of an understanding of where you're at. While you're completing that poll, I will introduce our first expert. Christian, are you happy to join us and get your presentation ready? Christian has a long experience in technical leadership of highly specialized teams of experts in a range of different areas. He's a naval architect by background, but combines that with great technical and commercial knowledge of the shipping industry as well. He's going to talk to us about Coach Solutions and how to manage and bring down CII in tramp shipping. So Christian, over to you.
Thank you, Nick. Hope you can see my screen now. So I'll be talking about CII and how to manage it, and hopefully also bring it down. I'm talking from the point of view of Coach Solutions that have specialized in making software for vessel performance and voyage optimization for quite some years now, but we've always specialized in bulk and tank segment that we were born out of. So the insights I'm going to share today comes from the conversations we've had with our clients, owners and operators over the past year or so when CII started popping up first. So what I'm going to go through is the CII measure itself and some ways to bring it down that actually also make commercial sense. Then I'll go specifically into the voyage optimization and how we see it as a great tool for managing the CII. And then finally, I'll end up with some recommendations that we see will help both owners and operators be able to manage especially some of the specific conflicts, you can say, that might arise when owners and operators have to share this responsibility of the CII. So to just start with the very simplified CII equation, then of course it's very simple math to see that to bring it down, you either need to reduce the CO2 or increase the deadweight tons and miles. And while you can increase the deadweight tons a bit, then that's typically a one-off. And increasing the miles is typically also not necessarily something that makes commercial sense, unless, of course, you're trying to avoid a storm. So the solutions I'm going to try and present now will mainly focus around bringing down the CO2 or increasing the fuel efficiency. The first one, which is unfortunately also one of the least feasible ones, is to eliminating or at least reducing this regime of hurry up and wait that has been a problem in modern shipping for as long as it has basically existed. The issue is that because of contractual terms that you have to sail at full speed to be able to claim performance, or there might be a terminal or a canal that you have to arrive at and give a notice of readiness, you have to sail fast, which of course is terrible for fuel efficiency and for the CII. And to make matters worse, then you arrive early and lie in wait for some days or maybe longer, which adds to the CO2, but without adding any miles. So this is double bad for CII. While this is a big systemic issue that is really difficult because of the many stakeholders and many people we talk to believe that this is never going to be solved, there are some good initiatives with just-in-time arrival, Blue WISP initiative, and so on. So I think this is a big problem that the industry together should continue on working on, even though it is a hard one to crack. Then, as you, Nick, mentioned, then we have the less CO2 intensive fuels. This is closer on the horizon, even though, as you rightly say, it is a big, there is a lot to overcome still. The fuel needs to be available and your engines need to be able to burn it. But if both of these very big ifs are satisfied, then you can basically start burning less CO2 intensive fuel and continue your operations as you usually did and get a lower CII in return. And then I move a bit into both the domain where we operate and also some tools that are available already now, and that if they are not being used, then it's probably a good idea to get started as soon as possible. And that is firstly to increase the general fuel efficiency of your fleet. This can be done with hardware, with energy-saving devices, or maybe even wind-assisted propulsion when that matures a little bit more. High-quality hull coatings has been available for a while now, and we are seeing more and more ship owners realizing that even though it's a big upfront investment, that comes back manifold during a docking period. And then finally, ensure to have a good condition-based hull fouling monitoring system to make sure you don't sail around with fouling more than you should, which is never, so you can identify it quickly and clean it off as soon as possible. And then finally, for the topic of the remainder of my presentation is, of course, increasing voyage efficiency by using voyage optimization tools to find the most fuel-efficient route, and maybe more importantly, manage the constraints that will be on that route. So to elaborate a little bit more on that, I'll try and describe the essence of what we see voyage optimization being. And this is from an algorithmic point of view, where you use a computer to solve this massive problem. So basically, it consists of some models that describe reality in weather routing or voyage optimization. This is a weather forecast, and then it's a digital twin that describes how the ship will react to being subject to the different weather conditions, different speeds, different loading conditions, and so on. But since there will be an infinite number of possible ways to get from one port to the other, we also need some constraints that make sure that the route we find is valid to the person calculating it. And of course, the list of constraints is long. First and foremost, we have safety, of course, which cannot be removed and never should. But then we have some other ones that might be possible to move. The one that I like to shoot at a bit is the CP terms, where you have to sail full speed and consumption in order to claim the performance of the ship, which basically limits the operator that is sailing or planning the voyage, that you can only sail at full speed. And this, of course, severely limits the number of routes that will come out of an optimization. If speed is not an issue, then typically an optimal route is found somewhere in the balance between the fuel price and the value of time or the value of cargo. And then, of course, there will always be an acceptable arrival time or an acceptable arrival window. And this is maybe also a constraint that can be moved or made more flexible, because that will open up to more, you can say, possible routes. But again, it doesn't really matter. Voyage optimization can, of course, deal with all of this, regardless of how tight or open it is. But there's no doubt that the fewer constraints there are, the more optimal routes can be found. And then finally, we have our new or relatively new emissions regulations that will also put some limits on what is acceptable. CII rating be the topic today. Tomorrow or next year will be ETS, and so on and so on. And then putting all this in a big computer and getting it to calculate, you will find a route and a speed profile that should be the most optimal way of getting from one port to the other and satisfying all of these constraints. And the output will be an ETA, total voyage cost, and a CII impact. So now I'll try and show how CII can be managed in a voyage optimization system, and I've chosen our own because that's what I have pictures of. But I know that this is possible in many other systems as well. So to just focus on the CII part of it, then the really important part is, and I'm sorry if it's a bit small, but it is really to have a good idea for the person optimizing the route, to have an idea of what will the estimated CII rating be upon completion of the voyage. And in order to calculate this number, you basically need two things. You need the CII before the voyage starts, which is based on historical data. And then you need a good estimate of what is the CII rating of this voyage in isolation. And that should, of course, include the port stay after the voyage. This is simple if you are owning and operating your own vessels, because then you have all this information at hand, hopefully. But if you're only operating a ship that you chartered in, then you might not have this information, because in order to do this successfully, you need to have the current vessel performance to get a good estimate of what kind of speed will I achieve in this weather with this consumption that I'm giving, and what is the starting point. And if either of these are wrong or missing even, then of course the end estimate is going to be very difficult to get, and you might start out with a wrong assumption, ending up in some overcorrections during the voyage. So this is really essential. So this leads me to the dilemma that we see very much that's going to be a thing with CII entering really into force next year, because there will have to be some sort of transfer of the responsibility for the CII during a charter period, and that is going to be give a big risk for both parties actually. So and some of the complexities that is causing this I've tried to list up here. So the owners don't control the vessel operations because they're chartering out the ship, but the charterers do, or the operators do, and they directly affect the CII rating. The charterers, as just described on the previous slide, need to know the vessel specification and the historical performance. The owners should know this, but the charterers only know as much as the owners have told them. So this can be, of course, a source of conflict. And then finally, there is also a funny thing here with the owners have typically been responsible for the weather performance. That's part of the contract that is given, but it typically only counts in good weather and sometimes also only at full speed. For the charterers, this is maybe a bit difficult because they are responsible for the CII, and this counts in all kinds of weather. And it actually also means that it counts at all speeds, and having to sail at full speed will typically be very bad for the CII. So if this is not handled or managed, then it will basically be great food for the lawyers, because there's going to be a lot of issues at the end of the thing. So of course, a great starting point, which I know has been going on for this year more or less successfully, is to develop some good charter party contracts or clauses that can handle this kind of complexity. But still, in order to have a good relationship and be able to transfer this responsibility in a good way, we already now see that there are some things that needs to be present both with the owner and the charterers, and that I'm going to present on the next slides. So for the owners, we see a big necessity now to have a hull fouling monitoring or performance monitoring system that can at all times tell and predict what is the current performance level of the ship. That can of course be used to identify and remove fouling fast, but even more importantly in this context, it can always tell you what is the current performance level of the ship. And the reason why that is important is that that can then be brought into dynamic speed consumption tables that can be used where you put in the actual performance of the ship. You can then generate a full draft range and speed range of the ship at the current performance level, because this is essential to be able to hand over to the charterers when you TC it out. This will also minimize your risk for performance claims, because you're not basing it on new building figures or inflated figures and so on. But that's of course a decision in the TC out moment. But it starts with having the information. And finally, for owners, it's also essential to have a good data collection system and a CII monitoring tool, so that at the moment when you TC out the ship on delivery, you need to also give the sail distance and the CO2 emissions year to date, so that the operator or charterer has a good starting point for knowing how's the vessel performing now, so that I can base my voyage on maybe having to sail slower, to make sure that I redeliver the ship at the right CII level. And again, it starts with the owner knowing it, and then of course it's up to them to share it. For the party operating the ship, voyage optimization, as I said before, is really crucial, because no human can comprehend this big mass of possibilities and constraints. So having a computer, a system do this for you is really, really important. So that's clear. And then we also see already now operators, charterers starting to work very much with owners to maybe get more honest or more correct, you can say, speed consumption figures from them, because it's going to be found out during the voyage anyway. And just, you know, being selective who they work with really gives everyone a good starting point for next year, when this starts being something that you need to collaborate around. And the owners that keep on giving inflated numbers will very quickly have a disadvantage, because in the end they might end up getting ships back at a bad CII rating. So this will probably be less preferred by the charterers from next year. So this leads me to my conclusion slide with some basic recommendations for how to manage the CII, especially in this owner-operator field. For owners, now more than ever is the time to have a good data collection system, because you need to be able to structure data, be able to share it, and then you need a good performance monitoring tool, so that you always know how is your ship performing, both in speed consumption terms, but also in CII terms. And then you need to be willing to share that data honestly, because it's going to come back in a positive way. For charterers, use voyage optimization software, because it's going to be super difficult to find the good voyage that you need to do that satisfies all your constraints, and you still want to make money on top of that, of course. So having to find that balance is going to be even more complicated next year, and even more in coming years, with even more regulations coming, maybe even different national schemes and so on and so on. And for both, I think working to remove some of these more the older constraints that are historical or systemic will definitely help CII, but will also help profitability and fuel efficiency in general. And a low-hanging fruit could be to, instead of only guaranteeing ships on a full speed, to maybe also guaranteeing a few slower speeds, or maybe even a full fuel curve, because that gives the operator a much wider range of possible routes to sail that will in the end allow them to also deliver back the ship at a good CII level. And then again, share data and information more openly. That goes both ways. Owners should definitely share more openly how is the ship performing, how has it been performing, while the operators should maybe also invite the owners in on their voyage decisions, so that owners can already early on in the voyage see some estimates and say, oh, it looks like this is going to result in a worse CII rating than we are comfortable with. Can we do something about that? Because it is, again, this shared responsibility that is really difficult. And I know this is all very utopian and so on, so this is going to move very slowly, but our hope is, of course, that CII, with all the flaws it has, can at least move some focus away from claiming each other to collaborating more. But of course, if that doesn't happen, then I'm sure there will be an army of lawyers happy to assist with settling the scores after these voyages are done. So that was it for me. Thank you.
Thanks, Christian. I've got just a couple of questions to start off, if I may. Yeah. The first, you mentioned around the complications and the difficulties of charter party agreements and actually having the right legal frameworks in place. I was wondering if you know of any good examples of where that's been addressed appropriately, and any insight you can share on actually how to go about that.
Yeah, no, we haven't seen anyone that are, seen as only good. I think the most famous example is the BIMCO clause, which was, of course, shut down pretty heavily as very owner-friendly. But at least it gave some ideas about also this, what kind of data is needed to be shared. So, the idea that the owner needs to give the distance sailed and the CO2 emitted to the operator or to the charterer is really essential to be able to for the operator to handle this responsibility well. So no, I think, of course, the central point is how do you quantify what it costs if the owner gets the vessel back in a bad CII rating? How much is it going to cost them the rest of the year if they have to operate it slower, or the lower rates they can give it out on? It's super complicated, and that's why I believe that it might be a case where contractual terms is probably not the right solution, but it has to be some kind of collaboration because it is both parties' problem. So no, I have not seen a good solution yet, and there might not even exist one.
Okay, interesting. I'll just take this opportunity to say if you have any questions for Christian or any of our panelists throughout the afternoon, please stick them into the Q&A box, and we'll make sure that they get answered live while we're on this session. Just one other is you mentioned about the importance of handing over frequently, effectively handing the problem back and forth between the owner and the charterer, and particularly around actually going about sharing the data. I would say as an industry, we're pretty bad at that. And I was wondering if you had any advice for both owners and charterers on how to actually set up that kind of data sharing setup to be able to effectively manage that sort of back and forth relationship.
Yeah, I mean, we have seen some interest popping up for involving verifiers in this question, actually, because they can act as an independent third party. So having the data from either the owner or the operator side, they will probably have data collection on both sides. But to have that data fed into a verifier automatically and have continuous verification on that, so that at the end of the voyage you can have a class approved or verifier approved document saying this is what happened. Even though it's not necessary from the rules, it might give the fact or stamp of approval that is needed to avoid having conflicts, right? So I think that is definitely what we see most people leaning towards involving these independent verifiers.
That's super interesting, because I think one of the really big questions is around trust, and just how do you go about achieving trust in that relationship without trying to bring an army of lawyers in. We've got some questions coming in from the audience, so thank you, keep them coming. The first one that's come up for me here is with regards to promoting openness. Won't the older, poorly performing ships always want to and need to keep things vague, i.e. make up missing consumption performance during bad weather days, etc.? What's your response to that?
True, but the problem is it's always going to be found out, right? Because as soon as you start sailing, it's going to be clear that it's a bad consuming ship. And again, it might not be, in the performance clause, if that is a really tight good weather clause and so on, that might not be triggered, but the CII clause will be triggered because that counts in any weather. So, and in the end, it's going to be the owner's problem if they have a really bad CII rating at the end of the year. And then it's up again back to the lawyers to find out how much money can the owner pull from the charterer, even though you could say it's kind of their own fault as well. So yes, it is a dilemma that you will need to. So that's again where I think charterers might, if they get burned like this from an owner with poorly performing ships, they might want to secure their risk by looking to more premium ship owners that might have higher rates, but you reduce risk, and then you might also be able to get more honest speed consumption figures.
Makes sense. There's two questions here mentioning AI, so I'll read you them both, and that's probably all we've got time for now, but we will absolutely be back to you at the end of the session. First, what method are you using for the optimization of the route, and are you using AI? And then the second is your solution also taking care of the data quality question for performance analysts and analysis? Sorry, and do you think AI-based measures are better than, for example, standardized measures, ISO 19030, exactly those types of things?
Sure. No, for our performance monitoring, we're using classical naval architecture methods, and we do that for two reasons. One is that we are dealing very much with a segment that is not very heavy on sensors. Ships tend to change hands a lot. So the good thing about the naval architecture based methods is that it works from the first day, and it is accurate enough to actually give a performance level that we need to do. AI-based methods are of course great. The problem is that it can take years to cover the full operational profile, and it will be very ship specific. So while that is very relevant for some segments like a liner service going back and forth or ferry, that is perfect for that. But for tramp industry, that is probably not the best way to go, not for us at least. And about our routing algorithm, it's not AI-based. It is you can say, a fresh slate every time. So we simply take our performance models and then put that through you can say, an optimization algorithm that basically tries out a lot of different routes, both in terms of space, but also in terms of speed variations. Which means that we are not stopped by what ships usually did, or we're not learning from previous experience. We're basically starting from a clean slate every time, meaning that we're not bound by what we used to do, which we think is the correct way to go.
Makes perfect sense. Makes perfect sense. Thank you, Christian. It was a fascinating discussion, and thank you for your questions. There was one that came up I saw about whether the session is being recorded or it's possible to get a recording. Yes, it is being recorded, and I'm sure if you ask the organisers, we'll send you a copy as soon as we're done. Quick time for a very quick poll before we move on to our next expert speaker. If I could ask Cameron in the background to push the poll, the first poll question online. How confident are you in your organization's ability to successfully implement greenhouse gas reduction measures to comply with new regulations? Not at all confident, somewhat confident, mostly confident, or very confident. We're really, really interested in seeing your responses collectively as an audience there. And we'll come back to the results once we've finished our next talk, which brings me nicely onto, I assume, a man who is at least reasonably confident, because they do have a strategy in place at D'Amico. Pasquale is the Deputy Head of Performances and Decarbonization at D'Amico. He's an MBA graduate and has undertaken several engagements with international organizations, including D'Amico Group, PB Tankers, Fincantieri shipyards. He's developed not only shipping industry expertise from that, but also a lot of transferable skills. And with the experience at D'Amico, he's worked in new building, looking at the group's fleet greening, so putting on advanced clean technologies, and then taking those ships into service through product tankers, bulk carriers, and containers. So really excited to hear what the strategy has been. So Pasquale, over to you.
Yeah, thank you very much. Thank you, everybody, for the invitation. It's always very nice to be here for open discussion. And most of the items that Christian has presented just now, it's our daily basis job. So what we are bringing today is, let's say, the experience of a ship owner. Let me share my presentation. Here we are. Okay. Okay, so today we are going to present what is the D'Amico strategy in terms of compliance of CII in relation of voyage optimization. We are going to see the D'Amico Group summary to understand what kind of fleet we are dealing with, fleet CII ranking distribution, factors leading the index rating, so the company strategy for the voyage optimization. So we try to answers to let's say subtopics that was presented by BS Group, and expected regulatory improvements from the end users as a ship owner, and we'll see conclusion at the end. So the Amico Group is a family business, is a family company that is in the industry since almost 70 years. And we have got mostly the fleet between bulk carriers and tankers. So we are covering all range of dry vessels and tankers. And totally we have 42 vessels on dry sides, and average age is 6 years. Comparing to the, let's say, the HIS market that is almost 10.8 years. And on tanker side, we have the Amico International Shipping that is listed in Milan Stock Exchange, where we have 36 product tankers with an average age of 7.6 years. So dealing with a young fleet does not mean that we are in line with the compliance with CII, as we can see later. We have 2 offices that dealing with the shipping management. One is the Amico Società di Navigazione, based in Holm, and we have also 100% management in Singapore under Ishima management. And for both technical management, we are covering as performance department, let's say a range of vessels of under 20 vessels totally, since we are managing vessels as spot and vessels under time charter out and vessels under time charter in. Looking into the, let's say, the present situation of our own fleet, we are having this situation. So for which just 25% of rating under bulk carrier side is subject to, let's say, subject to actions, and on tanker fleet we have 37% of the fleet. The correction, let's say, the factors leading the ratings, mostly when we start to deal with the CII ratings, we start to understand what was the behavior of our fleet. And as I said before, we have very young fleet, so for us it was not a problem to comply with the EXI. Just 7 vessels were forced to, let's say, install EPL, energy power limitation, but this does not tell the full story. As you can see here, we have 2019 trade and 2020 trade. So the same vessels, for example, dry 6 is having a different operative scenario, but you have a very big, huge difference in trade, let's say, in ranking. So 2019 E rating and 2020 we have a B rating. But the most important factor that we can see here for the CII, as already was presented by Christian, is the ratio between fuel consumption and deadweight. So smaller is the size of the vessel, and quicker you have the deterioration of CII rating. So as you can see here, we have divided between ND, Ultramax, Cancelmax, Panamax, and Mini Cape. So this is also valid for the tanker fleet. As you can see, ND sites, MR, and LR1. So this also is in line with the operative scenario of, let's say, smaller vessels, for which ND on bulk carrier side are suffering very long port stay, very long anchorage, so very also the extra fuel consumption for cargo cranes. And on the tanker side, we have the heating operation cargo that is very much affecting the CII rating. Other factors, we have port days, for which is very well known that are very deteriorating the CII rating. As you can see, higher is the port days and anchorage, and higher is the rating. So bad is the worst is the rating. as well as for speed effect, of course. When you're going to speeds over 12 knots, you will have higher chances to have bad ratings. And total miles effect, of course, you have better rating if you are sailing very much. So here we come to the ballast miles. That is really something that for which we were very surprised when the CII metrics was released with MAC 76, because as you can see here, higher is the ballast miles and better is the rating. So this is something that is in contrast with what is the CII, let's say nature. So it's a kind of indicator of inefficiency. So with the we are daily, let's say, trying to deal with to understand how to manage this kind of inefficiency value, part of CII. So as well for 2021 trading as pure CII, let's say AER, you can see here the directly let's say relation between port days and CII rating. So higher port days, you have higher CII rating. So in order to comply and to understand what is the behavior of each, let's say, unit we are managing, as I told you, we are managing vessels in time charter mostly, but we are also a part of the spot vessels, especially in 2022. We are managing quite large number of vessels in spots. So we are dealing with our stakeholders and let's say mostly oil majors and in the tanker side, as you can see here, where there is a good relationship, a well understanding of what is the CII metrics. CII metrics, you can see in this case, let's say the top part of the graph, there is a good behavior of the vessel, so good management. We let's say keep the vessel in A rating with a very optimal operation management. Instead, as you can see down, the dry dock, let's say, session plus long port stays spoiling the CI rating, and really this is something that, according to us as end users and as operators, it's very difficult to deal with, because you are not able, as Christian said, you are not able to, how to say, to justify when you are in port or you are in dry dock, you have very less consumption, but you are spoiling your CI without any reason. We are, let's say, as we can see later, we are in compliance with the ISM code and the requirement of SOLAS when you are doing the dock session, because you are obliged to do that, and unfortunately you have no chance to adjust the CII rating. So what is the company strategy? We have based our strategy on 4 main pillars. The first 2 are, let's say, mostly on the efficiency side. As we said, we have just 7 vessels for which we were obliged to install the overridable power limitation. But you know, this is just let's say forcing the vessel to don't go for an extra speed. So you are just setting the maximum speed. But already we have seen that in the last decades that we are going to very low speed. So this is not helping very much on CII rating. And on efficiency side, we are let's say we are installing many energy saving devices, but we are let's say preferring to install those devices with swift payback, since we strongly believe that draconian measures are not helping very much for the compliance. And of course, performance analysis is going hand in hand with digitalization, and for which we are, as we have seen before, we have built in-house software in order to track in real time the CII behavior, and any stakeholders can have access to our software in order to understand what is going on all over the year. At the end, we are, let's say, involved in alternative fuel projects, implementations, as we can see later. So mainly what we are doing in order to improve the CII. So there is optimum ship routing. We are applying through our software, let's say, to our forecast software supplier, and CII monitoring, performance monitoring in real time. As of now, we are receiving data from vessel as known data. So we are trying to compare our data with the sensor data in order to understand how much is the human error by reporting data. CBM, together with the hull degradation monitoring, we are understanding the overall performance of the vessel. So through the shock test of main engine, we understand what is the performance of the engine, and the hull degradation monitoring is helping us to understand whether there is how much is the hull fouling comparing to the first stage of paint installation, let's say. At the end, we install as a normal practice on routine basis every 6 months the propeller, let's say, inspection and polishing if required. So we have a big, let's say, data analysis. We have a big data to handle with. So our scope now, until when the new regulation for, let's say, promised by MPC 80, is to understand what kind of data are recognized, and what kind of data we are we need still to implement in order to bring added value to our analysis. So for sure, what is important for now is to always have a comparison with the benchmark, and to understand how much is the improvement in ESD installations or any kind of events such as dry docks or propeller polishing and hull cleaning, so on and so forth. So in order to reduce the human error on board, so let's say a captain that is increasing or decreasing the power, the RPM of engine, we are installing as pilot on 6LR an integrated system with let's say main engine managing control. So we are not setting any more RPM, but we are setting the speed of the vessel. So this is let's say a new technology that is helping us very much when the weather is very good to keep the speed as per charter party. When the vessel is going bad in rough sea, we are able to fix the fuel and the power in order to keep the consumption according to charter party. And we have seen that in the best scenario, we can reach also 6% of fuel consumption reduction. So this is always taking into account the safety part and also the commercial part of the voyage. So we are always open and happy to be, let's say, proactive, to have a proactive approach to understand what is better, what is not. Again, as Christian said, there are many ways to reach point A to point B, and we are trying to understand what is the best solution. So we compare. We are running many projects to understand the comparison between measured points, machine learning models, and digital twin. And also in this case, let's say on average, we can say that 3.5% is always reached. Of course, it depends very much on the length of the voyage and depending very much on the let's say weather scenario. So let's end up to expected regulatory development. Okay, MPC has been released finally, but as end users, what we are pointing out that is MPC strategy is still a strategy, and you know, the route, the speed is set, so we know very well what we are going to expect, but until when it's not translated into regulations, into rules, it's very difficult to implement new technologies, to implement new kind of fuels, because you don't know to which extent you can really save, let's say, save energy. So, as an example, I reported here let's say the improvement that we reach on tanker fleet due to the effect of correction factor between MPC 76 and 78. As you can see here on a large tonnage of tankers, we reach an average improvement of 3%. So for us, let's say introducing proper correction factors really it makes the things a little bit, let's say, stick to the reality of fact. So as correction factors under discussions, this was one of the subtopic that was presented by the BS group. We can see that the dead-off period, as I said before, should be excluded by, let's say, the counting of CII. And as we have seen here, no flag common criteria are there, because some flags are say, okay, you can do this, some other flags not. So also for us that we are dealing with many flags, it's not easy to understand how to approach, as well as for waiting time of port days that are irrespective of voyage durations. Fuel consumption for operations, also there. Interpretation MPC 78 is very hard to understand, and also there some flags are giving full fuel consumption operation to be exempted from CII, other flags not. Of course, there is the open discussion for low carbon fuel as a biofuel, and as you can see from last release of MPC 80. Also there is no flag, let's say, common criteria on how to deal with the drop-in of biofuel. So until when there is no release of LCA guidelines, it is very hard for us to implement, let's say, a routine strategy in order to face with CII compliance. So, by the way, we strongly believe that regardless what is the, let's say, the requirement of future requirements by IMO GHG standards, so we would like to be proactive part as end users. So I bring here one of joint, let's say, industrial project we've done with big players as Trafigura, ABS, RINA, Lloyd's, Phobos, Liberian Registry, and MAN in order to certify 6LR1 with the drop-in of biofuel B13 as second generation feedstocks, and we've seen that the test was very successful, and we have reached very good let's say, improvement of our CII rating, and for sure this will be our short-term strategy since ETS is going to be kicked in few months. So we end up in following conclusions that mostly are following what already has been said before by other presenters. So CII is of course is a metric of real operation goodness rather than design specification, as we have seen. Even though we have a very young fleet, a very energy efficient fleet, this does not mean that you are, let's say, having a good CII rating without a good operation. Smaller sites are suffering, tonnage are suffering the ratio between fuel consumption deadweight mostly. Energy saving devices are having very less effect on CII rating, so that we are prioritizing let's say energy saving devices with the swift payback, and of course should be changing of mind from any part involved in, let's say, in maintenance and performance analysis in order to have always the CII in check. So this for sure, when the CII rating will become official in 2024, this will have also commercial part, as Christian said, in order to have always the vessel at the best rating, will end up in a good commercial appealing. So that's all from my side.
Thanks, Pascal. That was fascinating. I think one of the things that struck me most was how much things that are outside of your control can impact your score. So, for example, dry docking or long port stays. And there's an interesting question that's come in, I guess, on one of the measures you're using to tackle that, condition-based maintenance. What methods have you been using for condition-based maintenance? And what's been the feedback so far? Are the data being analysed on board, or is it being sent ashore for analysis? And then how do you go about complying with cybersecurity regulations, or recent cybersecurity regulations from the IMO?
Yeah, actually, condition-based maintenance, we are not following only main engine and main generators. We are following also heat exchangers, pumps. So we are checking our energy efficiency in its full. So for sure, CBM is giving signals to understand where is the right time to let's say put your hands on your engine. But the most important part is the trend. So you are going to understand very well in advance when you have to deal with the machine. And the most important thing, of course, is let's say the tracking of torsiometer. That was one of the big deal when we received the new reports. You actually, there was very big influence of human error on that. So really, CBM is helping very much to understand what is the let's say the performance behavior of engines comparing to the hull performance. So you have a big differentiation between what is hull and propeller and engine part.
Yeah, that makes sense. And we're going to talk about the impact of the human element in just a moment. Thank you, Pascal. It was a fascinating discussion, and we'll have more time for some questions for you later on. But what I'd like to do next is open up our next poll. Cameron, if you could pull that onto the screen for everyone, please. What do you see as the biggest challenge in achieving CII compliance and voyage efficiency? Is it lack of technology, regulatory hurdles, financial constraints, or just simply lack of awareness and training? Please submit your answers now, and as with the previous poll, we'll use those answers as prompts for our panel discussion a little bit later on. I'd like next to invite our final expert speaker onto the stage, Harriet from Signal. We'll be looking at the impact of crew behaviour on efficiency from aviation to shipping. Harriet is the head of maritime at Signal and is responsible for implementing Signal software across the industry. Harriet's a deck officer by trade, sailing to the rank of chief officer before coming ashore and pursuing a career in software development. Harriet, over to you.
Thank you, Nick. So I would like to introduce an additional aspect to increasing efficiency and achieving those CII ratings and the continuous improvements. That your crew is your superpower here. I'm Harriet, as Nick very kindly introduced me, and I am head of maritime at Signal. And in just 9 years at sea, sailing to chief officer, I saw firsthand how the big effects that small decisions and attitudes of the crew were having on the performance of the vessel and the successful adoption of any new procedures and efficiency techniques that were being introduced. Let's take an example. As a crew member on board, I know that 10 a.m. is smoko time. That coffee pot is full, it's freshly made, and if I don't make it up to the crew mess in the next 10 minutes, I will be left the lukewarm dregs at the bottom of the pot. I'm tired after many days with broken sleep, and let's face it, I need that caffeine. I have 3 auxiliary engines running, and the load has just dropped. Do I take the logical decision to stay and switch off that engine that is no longer needed, or do I take the emotionally driven desire for a coffee break? Hey, it's only 20 minutes extra running time on the engine. Now, I think everyone listening can understand how that second option could prevail. But why? Well, because as humans, we need motivation to act. And at Signal, our hypothesis is that just giving a person the data and the logic found in a dashboard or a decision support system will not always induce an action. We've all been there, having implemented a new system, given the training needed, even if you've taken out tasks from someone to free up the time to use a new tool. And yet we still don't see the full potential of the new system. It's this gap to optimal performance that stubbornly remains. The question is, can we successfully close the efficiency decision-making gap in maritime? So in 2022, we partnered with BSM, and we did realize potential here with some staggering results. We saved almost an hour per vessel per day reduction in auxiliary engine usage and 4,000 tons of HFO on the main engines. There was, however, a long journey to get here, and that journey started in aviation. In the airline industry, the data is frequent, it's plentiful, it's accurate, and so it's the perfect place to start. On flight decks, we have seen some amazing results in motivating behavior change in airline pilots. So let me take you through how we did this, and then with the proof and the confidence that we gained on the flight deck, how we transferred this to the bridge and the engine room of a vessel. So the data from the aeroplane, it's that high frequency and it's accurate. The planes are all they're all similar, unlike the shipping industry. And the fuel saving practices, they're well defined and they're part of a pilot's training. The fuel efficiency software has been showing commercial pilots dashboards and highly accurate plane-specific data on their flights for years. And in this way, aviation is well ahead of shipping. These pilots, they're well trained, with many hours being monitored in simulators, ensuring that their standard operating procedures are clear, they're understood, and they can actually be carried out. They are actually well rested and highly paid professionals. So with this knowledge, training, and similarity, fuel-saving behaviors should be adopted uniformly across all pilots. No. Here we see the implementation of a fuel-saving behavior for an aeroplane pilot turning off an engine when they're taxiing down the runway. It's reduced engine taxi in, or RETI. Each of these blue lines is a different airline, and in each we can see the difference in those individuals implementing RETI. Some do it 90% of the time, and some hardly perform it at all out in the real world. So this is the true cost of personality and individual differences showing through. They're personality-led emissions. If this is true in aviation, where rigid procedures control so much of what is done by the captain already, just imagine the scope on a vessel, away at sea for days, even weeks, where the captain has a lot more autonomy and those operating procedures are much less standardized. So we ran a fixed effect analysis of historical noon report data and found a difference in how captains performed efficiency behaviors. And this was in exactly the same way we'd seen in aviation. But in shipping, it was much bigger. From over 150,000 noon reports from 430 vessels over 2 years, we found that decisions made by masters could account for as much to 5 to 11% of fuel consumption. With a gap this large, the true potential in maritime behavior change is shown. The next question is, how do we close this gap and increase the frequency of those efficient decisions? So we use behavioral science, and here's how we do it. We can use personalized, smart, data-driven goals that are based on the individual's past performance. I'm not talking about the ship's past performance, it's the individual's past performance. This makes them meaningful as well as achievable. So it allows that individual to measure their progress in a way that's highly relevant to their everyday actions. We also use environmental framing, and it gives the savings in real world terms. So simply saving your company money is not a motivating metric. But when you've been told that you've done the equivalent of planting 24,000 trees, or you've taken 22 cars off the road for a year, it's much more rewarding and motivating. And keeping someone engaged needs that carefully timed planning. No one wants to be bombarded with constant email messages, but well-timed engagement really works. And here's the proof. In aviation, we use those methods, amongst others, for Virgin Atlantic. And over 18 months, this is how we saw the change in behavior from a pre-nudging baseline. Before signal, reduced engine taxi-in, that's that turning off the engine when possible when taxiing, was being performed on average 36% of the time. When behavioral science was applied by signal, that goes up to 47%. With most captains that hardly ever performed RETI, they did it about 5% of the time, that's to the left of this graph here. You can see that most of them increased the frequency of this behavior significantly. In fact, some have even started doing it 100% of the time. So how do we adapt this to shipping? The main part of the process stayed the same. So that's steps 2 and 3 here. You launch your behavior change communications, but this time you use ship-based email inboxes as well as the app due to connectivity constraints at sea. And then you continuously test, measure, and optimize. But it was step 1 that needed the most adaptation. So that's finding those uniform behaviors when every ship is different and every situation seems to be different. Fluctuating market conditions, extreme differences in cargo handling requirements and procedures make it a really complex task, especially when the data to identify behaviors change was, let's face it, sparse. But with BSM, we found a partner that had already done the data side of things for us. And we were then able to identify the behaviors that could work across their vessels. We looked at auxiliary engines, seeing the way the energy demand on the vessel was being met, and that then we could address the behavior of turning those engines off when they weren't needed. We also looked at the main engine, and here we focused on a more generic metric of daily fuel consumption. With digital twins, vessel loading and hull conditions, as well as the external effects of weather and current, we had access to normalized speed fuel curves on which to then base an expected daily fuel consumption. The difference between that expected figure and the actual gave us the gap of opportunity there. And that's where we changed the behaviors and the attitude to fuel efficiency on board. When communications were sent by signal, using some of those behavioral change techniques that I've explained previously to 23 BSM vessels, we saw these staggering results. Here is that hour per vessel per day reduction in auxiliary engine usage, and that 4,000 tons of HFO saved in the main engine. That's about 5 tons per vessel per day average. In fact, these figures were so big that we went to UMass for a peer review of our work, and UMass gave us the green light and agreed that behavioural change alone had indeed worked to reduce fuel burn and carbon emissions. So since that initial BSM study, we've continued to save fuel on lots of different types of vessels, from tugboats to tankers, right up to those high-consuming container vessels. And this is proving to be a hugely effective solution to short-term emissions reduction, as well as priming our crews to engage with efficiency and all the changes that they have coming in this area going forward. The crew could be a key element in ensuring that continuous improvement of your CII annual reduction figure is achieved. So when we started in shipping, it was often thought that the crew could be unreceptive to this type of communication, that they would be unwilling to give us the time and the priority when their lives were already busy and full of high consequence decision making. However, this myth was busted as we found the crew reacted enthusiastically and positively to the refreshing way that these positive and dynamic, rewarding communications were sent to them. Aviation has known for decades that personality counts and that individual pilots vary in performance quite considerably. Here, though, the more traditional management interventions have started to increase tensions between operators, managers, and they've even started to agitate the airline unions. We can actually help maritime to avoid those same pitfalls, and we can go straight to this human-based motivational approach. As we move on with IoT data, we've been able to identify over 24 new behaviours to investigate and increase the sophistication of behavioural patterns and profiles at sea. There's so much more to explore here. So finally, our conclusion is that different people make different decisions. Now, what does that mean for our crew member at SMOCO time at the start? Well, option 2, go for your coffee before taking the engine offline. Well, it's not always the one taken. However, when we have proven that it is possible to preemptively, non-intrusively give positive motivation, that crew member who's normally drawn to the second opinion, the second option there, they will change their decision making. Our crew member can be given a reason and a motivation to wait for that coffee. And this makes huge differences when increasing efficiency today. So your crew actually are your superpower here.
Thank you, Harriet. That was quite remarkable. I think we spend so much of our time talking about algorithms and voyage optimization from shore and all of that sort of stuff that I think sometimes forget. That it's the engineers and deckies on board that are actually have the ultimate control of the vessel and can make what looks like relatively small changes to have a big impact. Just run me by those numbers again. That was it 30 ships or 30 individual captains and chief engineers at $3 million in 4 months?
Yes, so it was 30 individuals over 23 vessels, and the individuals being captains and chief engineers, and obviously they were changing vessels as well, which is why it was 23 vessels and 30 individuals. Right.
Okay. Wow. That's quite remarkable. Someone in the comments there has said, Harriet's hit the nail on the head. Well done. It is a continuous battle to ensure the crew thinks and acts towards the company's goals. I was just wondering if you could maybe speak on that a little. You mentioned about just driving cost saving, perhaps not being particularly motivating to crew members. Have you found any particular drivers work really well when you're messaging out to crew?
We have. One of them actually we found is to make charitable donations on the crew's behalf. That actually putting $10 in someone's pocket at the end of the month isn't actually that motivating either, unless you're giving huge amounts, unless it's going to be $1 million in their pocket at the end of the month. But $10, it's not going to change much. But if you tell them that $10 is going to be given to a charity of their choice at the end of the month, there's a huge motivational factor there, especially if you're a crew member. And we've just gone live with Stolt, who are doing this, and they're planting mangroves in the Philippines. And so if you are a Filipino crew member and you know that by doing your job properly, suddenly 3 mangroves are going to be planted in a nature reserve in the Philippines, that's a huge emotional pull. It's a really good motivator. And also we find that just recognizing the crew is the biggest thing here. The fact that there's been a lot of thought going into communications about the idea that you as an individual on board, it's not just the steel through the water, the ship, it's you as the individual on that ship are having an effect. The acknowledgement it's no stick. Normally you get the stick. It's you haven't done this. You get an email telling you what you haven't done or what you've done wrong, what you haven't done properly. If you are just getting acknowledgement for doing your job well, for thinking about these things and caring about these things, that in itself is a huge motivator for crew.
Yeah, I think that makes perfect sense, and I can see that in just in day-to-day life. For sure, there's definitely often it's the little things that motivate you far more than necessarily a big reward. Before we open up to a full panel discussion, I'd just like to, Cameron, if we can have the final poll onto the screen, and as we start to collect the answers for that, we'll bring all the polls up and just have a look at what the results have been. It's just coming in the next few seconds. Which of the following voyage efficiency measures do you find most effective? Speed optimization, weather routing, just-in-time arrival, or trim optimization? Speed optimization, weather routing, just-in-time arrival, or trim optimization? While people answer that, I'm going to come back to the previous poll we had, which was what do you see as the biggest challenge in achieving CII compliance? The biggest or the most popular answer at 31% was actually financial constraints. And Pasquale, I was wondering if we could perhaps start the panel discussion talking about that. You mentioned about actually understanding how to make investments into energy saving devices, and you're looking for investments that perhaps have a quicker payback. How do you actually go about assessing one mitigation measure against another and justifying the financial case? I think you're muted. Sorry, Pasquale.
I'm sorry. Yeah. Yeah, as you said, really our first approach was to understand what energy saving devices were fit with our fleet. So for sure, there are some devices that you are going to install only during the dock session as PBCF. And also for that, we are going to install on most of our fleet where it is feasible. So first of all, it's very important to have an asset that is updated under energy point of view. But there are really, as also presented by Harriet, there is a big room where you can improve your efficiency. So it does not need to reach draconian measures, because in the long run, you are having a big investment, and later on, the technology is changing. So you have spent very much financing for a kind of energy saving devices, for which later on the technology is changing, and later on you are not taking benefit of that. So for us, the power is that you cannot bring the power to zero, so the consumption to zero. So it's not a sum of energy saving devices that is giving you the decarbonization. So finally, for sure there is room to implement different energy saving devices, but with step by step, with a small investment outside.
Yeah, and I guess it's worth saying that it doesn't necessarily have to be an energy saving device to be able to improve voyage efficiency, as we've just seen with Harriet's example. There is low hanging fruit across all of the operation, and actually it's about making sure that we're helping to change those behaviors as much as anything else. There's a question come in from the audience, and again, I'll say if you have any questions for our experts, please pop them into the Q&A box, and we'll make sure they get answered. But it's a question for everyone, and I can see, Christian, you've already had a go at answering, so I'll come to you first. Most of the methodologies consider weather routing or route leg-based optimization, but what are your thoughts on optimization on the pre planning phase. So that's determining the ship voyage area and possible routes to approach transshipping with a more restricted operational area. What are your thoughts there, Christian?
So I think pre-fixture should be treated much the same as voyage optimization, in that you need a tool that can help you estimate what is going to be the consequence of doing one or the other cargo, right? And of course, voyage optimization tools, as I've written in my answer, can actually do that if they are able to use historical weather or average weather and so on. I think fundamentally that unless you really have to, then it's a bad idea to optimize anything for CII specifically, because of the issues with CII, you might end up doing some things that don't necessarily make sense. But of course, the estimates you do should definitely show also the impact to the CII of what you select to do, and that might be a constraint that helps you choose which is the best course of action. So I think that's my approach to that.
And Pasquale, I remember from your presentation you had some thoughts on the pre-voyage planning and actually how to go about optimizing that. What's your view on this question?
Actually, I believe we strongly believe in the voyage optimization in pre-voyage. That is, let's say, is an operation part. That's for sure. But during the voyage, that is I believe is something that we need to improve in. So the change of culture on board, because now there is a changing of perspective. The voyage was before and up to 2022 was planned by operation department on the commercial side entirely. Instead, now the perspective is changing. So there is a big impact on that, let's say, big impact from technical side. So during the voyage, we need constantly help with our, let's say, leveraging our digitalization tools in order to drive captains to bring the right decisions. Because sometimes they just stick on the charter party. They are afraid to don't, let's say, bring the vessel according to the ETA schedule with the operation and chartering department. So I believe that is the most important part where we need to work on, let's say.
And Harriet, building on that question around actually enabling captains to make better decisions, what the second biggest challenge in achieving CII compliance, according to the audience here, is actually lack of awareness and training. And I guess that speaks directly to the issue you're trying to tackle with Signal. I think often there can be a cultural issue within the industry around actually how empowered a captain or a chief engineer might feel to make a decision regarding their own efficiency. How do you tackle that at Signal?
My opinion is that the team that makes an efficient voyage isn't just the team on board. It's the team ashore as well. It's the vessel operators, it's the port operators. And often when you speak to the captains, they are frustrated. They say, well, I'm only working with what I've been told I have to do, with what I've been given. So in an ideal world, we would increase the people involved in the motivation here and motivating an efficient voyage to include those vessel operators and the port operators, because the port has to be, and it's communication between the team, and the whole team has to have the same motivation and be motivated by making that voyage efficient. And I think that's the ideal scenario. And in that ideal world, it will work. And actually with the tugboats in Hawaii that we were nudging, we ended up nudging the port operators as well to make sure that the cargo that was going to be transported by the tugs was ready on time. Because ultimately, if it wasn't ready on time, you've just increased the speed required to get to the next port. And actually, we were nudging port operators as well, and they were part of that team. And absolutely, they're part of the whole picture.
Yeah, I guess that comes back to going all the way back to the beginning, Christian, your points around it's not just the owner and not just the charterer. It's both parties equally, and as Harriet's saying, you know, you've got other parties involved as well when we consider how the impact that the port may have. It's very easy to sort of say that sometimes, but I think often the reality of managing all of those different stakeholders can be quite difficult. What's your experience within Coach about how your clients actually overcome that?
Well, some of them try, but basically give up, because it's not just owners and operators, it's also cargo owners, and it's the Panama Canal, and it's you know, big things that just are really difficult to move, right? So I think the best examples we are seeing is big operators or big pool managers that have some leverage, and then push their owners to need to collaborate. I think sometimes the stick works a bit there, and say we only want to work with owners that will give us the necessary information, that are willing to cooperate. So that's of course also a way to brute force it a little bit, and that might be necessary in some cases. But yeah, I mean, convincing the Panama Canal that you can have a virtual arrival put in, that's probably a bigger thing, and that maybe something that really needs to be moved to a high level, right, to fix. And that's why there are a lot of especially experienced shipping people saying that this is never going to be solved. So we'll have to manage within whatever constraints we have.
Makes sense. Yeah, I think we're always battling against the fact that we are just a very large, international, very complex industry, and so it's always going to be challenging to bring everyone along. I'd like to talk, if I may, about just the data collection as a point. Pasquale, I'd be interested, particularly in the D'Amico fleet, actually how you've gone about. You've obviously quite far evolved in your data collection setup, and you mentioned in your presentation about trying to eliminate human error from data collection. What does that actually look like in terms of your fleet? Is there a particular technology that you've installed to enable that, or are there particular processes that you've developed that make that possible? Because I feel like both Coach Solutions and Signal rely on there being good data available to be able to do any optimization.
Yeah, for sure. For sure, the optimization is part of our process in order to bring the high reliability of data we are receiving from the vessels. So, we still strongly believe in what is the captain and chief engineer decisions in different conditions. So, by the same time, we like to to compare with the sensor data in order to understand really what is going on board, what is the real energy efficiency of the vessels, because we are quite lucky that some vessels are sister vessels, so we are able to compare the behavior, and so we can timely understand what we need to do during the dry dock session. So on let's say time schedule maintenance on board. So for sure the digitalization it's helping very much, but on the other side, you can also lose a lot of time of your daily job try to understand what digitalization is giving to you as additional information. So sometimes the hydrodynamics fundamentals of naval architecture is, let's say, we can say it's quite simple. So really the first scope is to understand what is the energy efficiency of the vessel, and to really bring let's say the carbon footprint as much as possible down.
Christian, I'd be interested to know from your perspective, just building on those comments around how you actually normalize for all of the different conditions that a vessel may be sailing through. No two voyages are the same, and even when you've got sister ships, no two ships are really the same. So going sort of beyond CII as a measure, how do you actually kind of normalize that to find the true efficiency of a ship?
we are using a naval architecture principle, as Pasquale is mentioning, and again, the reason for that is that this is the best solution for a very varied fleet and a relatively unknown fleet as well. Sometimes, right? We need relatively little data to be able to actually build a model that can predict things well enough to determine the fuel efficiency. But it of course even more relies on the data that we then take in to use for adjusting the model and finding the performance level, because we hear a lot of people talking bad about noon reports and so on, because that has historically been of a very low value. But we try and improve the level of that by having an onboard tool that helps validate the entered data, and then we enrich it with AIS data and weather data from our weather providers, meaning that even though the data is manually entered, and we do a lot of things that Harriet is talking about as well to try and make the crew understand what is actually the data they're entering used for by giving them feedback. So all these initiatives together do that we can, with relatively simple measures, do some very detailed analysis that would otherwise require some very expensive installations for sensors and data transfer and so on. But of course, once owners get to that level, we do have ways to start slowly taking sensor data in, initially maybe to just pre-fill a field in the noon report, so you don't have to take it from a piece of paper into the thing, but you can just press a button and get the aggregated figure directly from the control system and something like that. And then of course all the way to high frequency performance analysis and so on. But for the majority of our fleet, we still see that this enriched noon report, you can call it, is working very, very well, and there is not a lot of push to move away from that, because the cost is so high and the relative benefit is actually quite small.
I guess taking that question one step further, Harriet, no two captains or chief engineers are the same based on your presentation. So we're now not just optimizing for the vessel or the route or the weather, but we're also optimizing for individuals. How do you actually pinpoint an individual's performance? Because I can see that would be really difficult to do.
It is really difficult, and you need a lot of historical data, and you follow an individual back across different vessels. And then when you start following them across many different vessels, you start to create this pattern of behavior. It's often not 100%, because especially when you're dealing with noon reports, they are a snapshot in time. You're never going to get 100% accuracy there. But then when you're looking at a difference in behavior, all you're doing is comparing a difference. So it's apples with apples. You're comparing, and you can see the differences. And what's really astonishing is you can see these behaviors when you then track them on different vessels as well. So you can then compare them to other people on that similar vessel in similar situations, and then really see that there are differences in behaviors, because we are all different. And I think one of the things we've found is that there are very few generic bad captains or chief engineers or pilots out there. You'll find some are really good at doing certain behaviors, whilst others are really good at doing others. They just have different focuses, different things that are good to them. But one of the things we did notice and have noticed in the trials that we've done is one of the first things we see is that the data quality coming from the vessels that we're on increases. That suddenly the crew caring about, or even seeing that data, caring about that data, the quality increases. Because there's that fuel flow meter that's just that quite hard to get to, that never really gets calibrated properly. All these things. Your vessel, that you can manipulate the data going ashore. You can. But if that's being fed back to you in this way, and you care about it being accurate, it makes a real difference to the quality of data that you get.
Yeah, that's an interesting loop, isn't it? I guess when you start sharing the data and people can see it, the data gets better, and then everyone's motivated to do better.
Exactly.
Really interesting. Okay, unfortunately, I feel like we could go on for hours actually discussing all of this, but we are running out of time. So I'll ask perhaps each of our panelists to give just final words of wisdom, words of advice to owners and operators who are now looking at implementing CII, certainly implementing CII, but ideally implementing voyage efficiency as best as possible. And then second, if anyone has any follow-on questions, where should they go to find you to find out more information? Pasquale, why don't you start us off?
Yes, for sure. Now we have ETS and fuel that starting to bite in 2024. So this is a very big challenge. So we are touching also the pocket of parties involved in the CII compliance, I say, and carbon footprint compliance. So basically, according to me, the awareness is going to help very much. So awareness of all parties involved, because as I understood so far, we only technical people are discussing, mostly are discussing about this. So I believe that coming back to CII topic, let's say, once in 2024, 2025 will be come official that this vessel has this kind of, let's say, rating. So we come to the paradigm that planning, monitoring, and corrective action with the same part 3 will become really daily bread for everybody of us. So awareness for sure will help very much to be in line with the IMO, let's say, strategy.
Thank you, Pasquale. Thank you for your excellent presentation and your interesting answers. Harriet, final words from you?
Yeah, I think just don't forget that people that you are relying on to make those voyages that your vessels are doing as efficient as they can be. They are making decisions on a daily basis that are affecting efficiency.
Perfect, makes sense. And Christian, last word goes to you.
Thanks. Well, I think first I'd like to echo Pasquale, because we see, especially with the most commercial part of the businesses, that CII is very, very low on their radar, and it will be their initial decisions that's going to be affecting a lot. So in order to avoid, a long running in period where a lot of bad decisions are going to be made, they should really be aware of what's going on. And then, as I said earlier, I think if you as an owner or operator does not have a good data collection system in order and are still relying on Excel sheets and stuff like that, this is really the time to get going, because this is not going to fly next year.
Yeah, that makes perfect sense. I think for me, the big takeaway is really there is no silver bullet, whether that's technological or one around decisions, or internally within an organization, or even externally across the entire industry. There is a huge amount to be worked out, and the range of things that can impact your CII rating is wider than I initially thought it was coming into this call, whether it's dry docks making a big difference, or the chief engineer wanting to take smoke home. I'd like to take this chance to thank all of you for taking part. It was a fascinating discussion. Thank you to the audience for your interesting questions. Thank you to all of our speakers, and also to our session sponsors, Coach Solutions and Signal. And lastly, thank you to BS Solutions for actually pulling this whole thing together. I'm sure we'll see you on the next one, and I hope you found it informative. Goodbye.
Goodbye. Thank you.
Thanks, Nick.